On to homework 11. First bit of this homework is about law of conservation of mass, and it asks you to define that. Now, if you can't remember the definition, it is in the glossary, so look up conservation of mass in the glossary. It's all alphabetized, so it shouldn't be too hard to find. But essentially, the law of conservation of mass is the first law of chemistry, and it's the most important law of chemistry, really, which is you can't destroy matter or make matter. So in a chemical reaction, the atoms in the reactants are rearranged to become products, and no matter is gained or lost in that reaction. So the mass of atoms at the start must equal the mass of the atoms at the end. The next couple of questions are simply about applying that. So a chemical reaction takes place on the top-hand balance, and as the reaction takes place, the balance shows the mass of the flask is decreasing. What can we conclude? Well, that's not magic. Okay, the atoms in the flask are not destructing. They're just leaving the flask. So if mass is going down, it's often because something's been given off, probably a gas. Okay, so use that same logic and try and apply it to the next question as well. Question number 4. In an experiment, 2.8 grams of iron react with 7.1 grams of chlorine to make iron chloride. What is the empirical formulae? So this is an empirical formulae calculation, absolute classic calculations in the Excel specification. So I'm going to do a different one. I'm going to say, what shall I say? I'm going to say 0.7 grams of lithium react with 0.8 grams of oxygen. Okay, what's the empirical formula of lithium oxide? So I'm going to do a different question as this one, same method. Now to do these, we divide our bit of paper in half to start with. And on this side, we're going to write one of the elements. On this side, we're going to write the other. So I'm going to write lithium here and oxygen here. You're going to write iron and chlorine, okay? Because we need to do 2 calculations. So there's lithium there, oxygen here. On this side, we write our most important formulae in chemistry. Moles equals mass divided by atomic mass, relative atomic mass. And we're going to do that for lithium. And we're going to do it again for oxygen. So write it out twice, please. Because it just shows whoever's reading it that you know what you're on about. So the mass of lithium, we know a mass when we see it because there's a unit after it, is 0.7 grams. 0.7 grams is the mass of lithium. In the question here, we've got 2.8 grams of iron, so that's the mass of iron. Divided by lithium, the atomic mass of lithium, if I look on the periodic table, we can see the relative atomic mass of lithium is 7 and oxygen is 16. So that's always given for you. There's iron and chlorine. So they are the atomic masses. 0.7 divided by 7 equals 0.1. Okay, do the same for oxygen. Mass of oxygen, I've said there's 0.8 grams. And the relative atomic mass of oxygen is 16. So 0.8 divided by 16 is 0.05. So our formulae, our empirical formulae, is Li 0.1, O 0.05. And you may think, job done, that's correct, and it is, I suppose, but we report empirical formulae to the smallest possible whole number. Okay, so we don't have decimals. So we need to look at the relationship between these numbers and report it to the smallest possible whole number. Now, the question you have to ask yourself here, the first question you have to ask yourself, are these numbers the same? And the answer is no. If they were the same, the formula would simply be LiO, but they're not the same. It's because we're looking at a relationship between these two numbers. Second question you have to ask yourself then is, which number is bigger? Okay, is 0.1 bigger or is 0.05 bigger? Answer, 0.1 is bigger. So in our empirical formula, there is more lithium than oxygen. Now that's important because people often just get these the wrong way around. Lithium number is bigger. We can see that. 0.1 is bigger than 0.05. Final question, how many times bigger? Now if you can't see how many times bigger it is, take the big number, which happens to be the lithium, and divide it by the little number, 0.05, and the answer is 2. That tells you how many times bigger it is. Sometimes these numbers are difficult and you can't see how many times bigger it is. Take the big number and divide it by the little number. So our formula is Li2O. That's for my question, but you've got a different one in your homework. Once you've mastered it for that question, you need to master it for question number 5 as well, because that's also an empirical formula question, exactly the same method. Question number 6. difficult question is because it's not one that you've been taught, but you are expected to have some mathematical skill. If this pitched up on a GCSE exam, I don't expect many people would get it right, but it's not that difficult once you have a go at it. So a lot of people see things and just panic, but actually if it's a question you haven't seen before, it's probably quite straightforward. So it says ammonia has a formula of NH3. Calculate the mass of hydrogen in 50 grams of ammonia. Give your answer to 3 significant figures. Right, so what's missing here, and this will be in your book next time you see it, is the relative atomic mass of nitrogen. The relative atomic mass of nitrogen is 14, and hydrogen is 1. I should have put that in the question, and I shall add it straight away after I finish this video. Okay, so I'm going to do a different one. I'm going to say calculate the mass of, I'll do hydrogen again, of hydrogen in 20 grams of methane. Methane has the formula CH4. Okay, so the first thing we have to do is we have to work out here the relative formula mass of ammonia. Now, this is a 3-mark question, so even if the only thing you do is say ammonia, or methane in this case, I'm doing methane, is carbon plus hydrogen plus hydrogen plus hydrogen plus hydrogen. And then you say, well, carbon's got an atomic mass of 12 and hydrogen's got an atomic mass of 1. You then look at these atomic masses and go 12 plus 1 plus 1 plus 1 plus 1, and that's 16. That'll get you your first mark. So you do that for ammonia, that gets you your first mark. So, and this is where really great students can hoover up marks in the exam, even when they're not quite sure what they have to do. They just have a go. And you get marks for that. So you're doing this for ammonia, remember NH3, I'm doing it for CH4. Okay, so when we've done that, we want to know what mass there is of hydrogen in that methane or in that ammonia. Well, how many hydrogens are there? There's 1, 2, 3, 4 hydrogens. There's 4 hydrogens in that methane. So how do we say in that? In maths, we say divide. There's 4 hydrogens in that methane, so 4 divided by 16. That's the proportion of hydrogen in methane. And we want to know that in, I said in 20 grams, didn't I? I said in 20 grams from my question, you got 50 grams in yours. So I'm going to multiply that by 20. Okay, so 4 divided by 16, that's 0.25 times 20, a quarter times 20 is 5 grams. So my answer to how much what mass of hydrogen in 20 grams of methane is 5 grams. Now, you're not going to have such a neat sum because it asks you to do it to 3 significant figures, and so be careful of rounding in there as well. But hopefully you can see that isn't as tricky as maybe it first appears. It is very tricky, having said that. So just have a go. Just have a go. And even if you only pick up 1 mark, I'll be pleased with your efforts. Next question. How many atoms are present in 2 moles of aluminium atoms? Okay, again, a question that blows the minds of most chemists, but if I said to you, how many eggs in 2 dozen eggs, you'd say to me 24. I would say to you, what maths did you do? And you'd say, well, 2 times a dozen, 2 times 12. And that's the maths we're going to do here. It's the number of atoms, okay, number of atoms, okay, equals the number of moles, or, number of dozen if you like, 2 dozen, 2 moles, times the constant. And the constant for a dozen is 12. The constant for the number of atoms in 1 mole is 6.02 times 10 to the 23. So there we go. That's what we're going to do. Stick that in a calculator. Stick the numbers in there, stick it in a calculator. You'll come up with an answer. Next question. What is the mass of 2 moles of aluminium atoms? Okay. Now again, if you're really clear with your chemistry here, you're thinking, oh, this is a nice straightforward one. Well, the Avogadro constant turns the atomic number into a number of grams that you can weigh out. So 1 mole of aluminium weighs 27 grams. That's what that means. That's what the Avogadro constant is. That's what the mole is. So 2 moles is simply going to be 2 times 27. Work it out. Okay. Final one. What is the mass in grams of 1 aluminium atom? Okay, well that's going to be shockingly tiny. Remember, this many aluminium atoms weigh 27 grams. Okay, so 27 grams, okay, is that many aluminium atoms. All right. So we need to divide the 27 grams by that many atoms to work out the mass of one atom, don't we? And think about it in reverse. If we have the mass of one atom and we multiply it by that, it's going to equal 27 grams. So it's simply 27 divided by 6.02 times 10 to the 23 should give you an answer. As I said, some really difficult questions here. Number 6 is pretty horrible. Number 7, that's not nice either. Number 8, that's so straightforward it would catch most people out. And number 9, that's really quite horrible. So this homework is very, very tough. I'm not setting easy homeworks, and that's why you have videos to help you. Do ask if you're not sure.